Hello, ladies and gentlemen, and welcome to another edition of Algebra 3 video notes. We're going to jump into 6.7 today, where we are going to tie the graphs of our polynomial functions to the equations. And we're also going to analyze a graph of a polynomial function. So you can see the two learning targets on the screen. I can describe the end behavior of a polynomial, and I can use the graph to analyze a polynomial. You should have a note sheet ready to go. There is one posted in Google Classroom in case you need access to it, which will allow you to follow along and jot some notes down on that note sheet to help you study at a later point. All right. Here we go. So our end behavior of our polynomials really is connected to the degree of the polynomial. All right, so let's review a little bit. Again, starting out here on the left, a linear function that just has an x to the first has a degree of 1. A quadratic function, which has a degree of 2, would have an x squared in it. A cubic function, x to the third. Quartic function, x to the fourth. And a quintic function would be any function that has the highest power, x to the fifth. Notice, for each one, the graph has a distinct shape. Okay? And what's more important to notice is that, is that the x squared and the x to the fourth behave differently than the x cubed, and x to the fifth. These differences will allow you to analyze the graphs. And as you'll see in just a moment, it has to do with where the graphs start and finish. And there is a difference here, depending on whether or not it's an odd power or an even power. All right, as you can see on these graphs, when it's an even power, so x squared, x to the fourth, x to the sixth, the polynomial graph finishes in the same direction on the left and on the right. So for this squared function, they both finish going up. Same with the fourth function. Notice on the odd-powered functions, the graphs finish in opposite direction. One side goes to positive infinity, the other side goes to negative infinity. So there is a difference depending on whether it's an odd degree or an even degree function. All right, so we call this end behavior. What's happening at the end of the function? And when we talk about end behavior, it's important, if we can look at the degree, to then know about the end behavior of a function, especially if I'm going to have to graph that function. Okay? And here's how we look at it. We're going to describe it in terms of x approaching positive infinity. So what's happening on the right side of the graph, and as x approaches negative infinity on the left side of the graph. What we have noticed, and what you viewed on the previous slide, is that when we have an even degree function, the end behavior is the same. Okay? And in an odd degree function, the end behavior is opposite. All right, so the degree tells us how the two sides of the graph behave, either the same or opposite. The leading coefficient can tell us which direction the right side of the graph goes. So if you notice here, if the leading coefficient is positive, okay, let's say I'm graphing 2x squared. The 2 is positive, right? The 2 is positive. That will tell me that this graph on the right side will finish up, okay? And because it's even, both sides behave the same, and the left side will finish up. But the positive 2, the leading coefficient, tells me that the right side finishes up. Mathematically, it says, as x approaches positive infinity to the right, the function also goes to positive infinity, which means the y values are going up. Okay? If we come across a function where the leading coefficient is negative, notice now the right side is going down or to negative infinity. Okay? When you have a positive leading coefficient, the right side is going up, and when we have a negative coefficient, the right side is going down. So as x goes to positive infinity, now the function or the y values are going to negative infinity or down. Okay, very important. And once you know what the right side is doing, you also know what the left side is doing, because the degree tells us it's either the same or opposite. Okay, so we can put all these ideas together now, and I have in the notes. Okay, so notice here we have this chart that is divided into two columns. Okay, two columns here, either odd or even. Okay, notice on the even side, each side of the graph is finishing in an opposite direction. For the even degree functions, they're each finishing in the same direction. Okay? So what that means is if the leading coefficient is positive, and we're going to call the leading coefficient A, when it's positive, greater than 0, on the right side, the graph is finishing up. Okay? The function is going to positive infinity as x goes to positive infinity. The even side finishes in the same direction. The odd function finishes in opposite directions. Positive number leading coefficient finishes going up. Okay. Notice how we write that. As x goes to positive infinity, the function is going to positive infinity on the right. And when we say x is going to negative infinity, this is talking about the left side of the graph. Okay. This is talking about the left side of the graph. This is talking about the right side of the graph. Now notice on the second row of the column, now we're talking about when A is negative coefficient. Now notice where both sides, right sides of the graphs finish. Both right sides of the graph finish going down. Down means the function p of x is going to negative infinity as x goes to the right. They're going down. Again, if it's even, it finishes the same way. Right? This is an even function, so it finishes in the same direction. And if it's an odd function, if it finishes up as x goes to positive infinity, it's going up. Then on the negative side for x, it's going down. Okay? If it finishes negative, it's starting positive. Okay, that's an odd degree. So some examples now. Okay, here it says identify the leading coefficient, the degree, and its end behavior. So as we start out, we are going to look at this first term is going to be crucial. So the leading coefficient is positive 2, and the degree is 5. Okay, that tells us two things. That is going to tell us two things. So what is it going to tell us? All right, so that tells us, because the leading coefficient is positive, that tells me that as x goes to positive infinity to the right, the function is also going up or to positive infinity. Because the degree is odd, that means that on the left side, so this is the right side, on the left side, in other words, as x goes to negative infinity, the function is going to behave opposite. So instead of going up, it's going to go down. Okay? So when it goes on the right, it's going up, and on the left, it's going down. Okay? Second example. Now, if we identify the leading coefficient, okay, the leading coefficient in this example is negative 3, and the degree is 2, which is even. So we have a negative leading coefficient and a degree that's even. Okay, that tells me when I investigate what's going to the right, because the leading coefficient is negative, on the right it's going to be going down. On the left, because it's an even function, it's going to behave the same way as the right, so it's going to be going down. So if we write that mathematically, as x goes to the right or to positive infinity, the function is going down, which means the y values are going to negative infinity. Now, as we go to the left, as x goes to negative infinity, the function is also going down to negative infinity. Okay, now notice here we have the graphs given to us instead of the equation. So we're going to, in a sense, work backwards or in reverse. So let's get after it. So it says, does it have an odd or even degree? And does it have a positive or negative leading coefficient? So two items, okay? So odd or even, all we have to do is investigate where it's finishing. Because the finishing the finishing directions are opposite, that means it has an odd degree. Then we investigate what's happening on the right side, and in this case, the right side is going to negative infinity, which means it must have a negative leading coefficient. Second example, okay, second example. Now notice, as we look at this second graph, if I look at both ends, they are both finishing in the same direction. Therefore, this is an even degree polynomial. And then we investigate what's happening on the right side. On the right side, it's going to positive infinity. So we have a positive leading coefficient. All right, to summarize, notice on the left here, I have even functions. What do you notice? They both finish in the same direction when they're even. The difference, they're either both finishing up and both finishing down. Over here, we have the odd functions. Notice they finish in the opposite directions. Again, if you need to pause the video, it's important that you understand how to write these mathematically, okay? In other words, as x goes to the positive infinity or the right, the function is going up. And as x goes to the left, negative infinity, the function's still going up. So you should pause and make sure you understand the mathematical notation. Otherwise, I've got a couple questions for you to answer here to finish up your work.